Okay, guys, now we're going to move on to atoms and then elements. Okay, so atoms and then elements, A-T-O-M-S, not A-D-A-M, Mr. Hinkin. Okay, so here's what I want you to do. Turn to page 633. On 633, they're going to have you draw a carbon atom. Okay, now a couple things you need to remember about the atom. Number one, it's the smallest building block of any piece of matter known to man. We are not able to see it with the unaided eye, and an atom cannot be split into pieces. We talked about that. There is no human way possible to split an atom. It is the very smallest unit of matter. Absolutely point blank. So, we're going to draw a carbon atom. So if you remember, we looked at the periodic table of elements, okay, and carbon was number 6 on the periodic table of elements. Some of you may have actually made this atom when we did it with the wire and the pom-pom balls. So this might actually be kind of a refresher course for you. So every atom has an inner core, kind of like the Earth, and inside of that inner core we have the protons and the neutrons, okay? Now protons have a positive charge, neutrons have no charge, okay? They're neutral. So protons positive, neutrons no charge. So if you look on page 633 there where it's telling you to draw a carbon atom, they're telling you that carbon has 6 protons and 6 neutrons. And you can figure that out based on the atomic number that is based on the periodic table. Here you see carbon and it's number 6, which means it has 6 protons, and the number of protons that an atom has is equal to the number of neutrons because they kind of have to balance each other out. So I'm going to draw this as you guys draw it as well, so make sure you're working along with me. So I'm going to draw in my 6 protons, and I'm going to put them as plus symbols so that I know that those are positive charges. And then neutrons have no charge, so I don't want to put them as a negative symbol because that would be like an electron, so I might just do circles. Okay, so there is the nucleus of my carbon atom. Okay. My green pluses are my protons, and my red circles are my neutrons. There are 6 protons, 6 neutrons. Now we have to think about the electrons. Now the electrons can be calculated, if you guys remember, by taking the atomic mass, which is at the bottom of the element. So the atomic mass is 12, and it looks like 1,115 10,000ths. So if I take 12, we're just going to round it, okay, because that's a really small number. 12, and subtract it from the atomic number 6, so I also have 6 electrons, because I simply take my atomic mass minus my atomic number, and I get my number of electrons. Now, if you guys remember, those electrons are swirling like bike tires around the outside very, very quickly, and they only can have so many electrons per shell layer. Okay, so I'm going to draw the first shell layer. Okay, do you guys remember how many electrons are allowed to be in the first layer? So here's my valence shell. You're allowed to have 2. So I'm going to draw these as negative signs and circle them just because I'm using pen. Okay, so there is my carbon atom so far. Now I still have 4 more electrons, so I have to draw another valence shell. And I have to draw the remaining 4 electrons in that valence shell. So there, ladies and gentlemen, is a carbon atom. Now, I'm not going to ask you on your assessment to be able to draw one of these, recreate them. What I do want you to be able to identify is the functions, the jobs of the different parts of the atom. So you need to talk to me about the protons and the neutrons and the electrons. You should be able to reason why we have the same number of protons as neutrons inside the nucleus. Why wouldn't I be able to have 6 protons and 2 neutrons inside of the nucleus? Okay, think about the balance beam that we talked about in class. That's a really good example to kind of help you think about the structure of an atom. So the 3 things you need to make sure you have down big time would be the terms proton, neutron, and electron. And you need to know the type of charge that each has, because every single atom known to man has these 3 things within. Okay, so when I take atoms and I put them together like atoms, and I put them together, so if I have my carbon atom and I'm going to take out and I'm going to grab Elisa's carbon atom and I'm going to put them together, now I have an element. Okay, when we have 2 or more atoms of the same type, We put them together, we get the elements. Elements make up every single thing we know. Every piece of matter known to man comes from this chart. We talked about how crazy that really is when there's only, on this chart, 103 items. Only 103 elements on here, and everything we know is made of a combination of these. Okay, so when I take two or more atoms, I put them together, I get myself an element. Now an element is pure because it's only one type. It has the same type of atom. Okay, so the elements are up here, and some common ones that we listed that you probably should know, and we talked about that in class, would be hydrogen, carbon, nitrogen, oxygen, neon, you can know that one, helium, and probably iron, which is Fe. Okay, many of you researched that one as well. Some of these other ones, you can look up. You can ask Mr. Pinkerton, or you can check with me on the types. But you just need to make sure you know that the elements are formed when we take atoms that are the same, the building blocks, the smallest piece of matter, we put them together, and then we have elements, okay? And elements make up everything that we know. So atoms, elements, be able to identify those, be able to look at different examples. I want you to put something on your poster that kind of helps us to get that down. It's totally up to you what that is, okay? But I want it creative, okay? And I want it your own work. I do not want something you just draw right out of your notebook. Okay, guys, you're trying to get this material down. You're trying to master it. I want to see what you got. Off to the next station.